Hello, my name is Cecil, and today I'm going to be walking you through a Physics 211 problem. For this problem, we're going to be looking at a 40 centimeter by 60 centimeter pane of acrylic at room temperature, and we're going to find how much the area of the acrylic panel will change if the panel was placed in a high temperature stove. What we know, if we make a diagram, which I'll do real quick here, if we start off with some length 1, which is going to be the length across the panel, and then a second length, which is going to be the vertical length of the panel, then we know that after the temperature is raised by some amount, the panel is going to expand, and the amount that it expands is going to be equal to the change in the first length plus the original length, and then vertically the change is going to be the length from the top of the panel to the bottom plus the change in the second panel. So that means that our new lengths, or our final lengths, so L2F would be L2 plus the change in L2, and L1's final length would be equal to L1 plus the change in L1. How are we going to find the area? Well, we know that the final area is going to be equal to L1F times L2F, and we know that L1F and L2F are the values described above from the diagram that we drew. So we know that L1F is equal to L1 plus the change in L1, and L2F is equal to L2 plus the change in L2. How are we going to find the change in L1 and the change in L2? Well, we know that in order to find the change in any given length for linear expansion, we know that it's going to be equal to our coefficient of linear expansion times the given length times the change in temperature. So we can say that the change in L1 is going to be alpha times L1 times the change in temperature, and the change in L2 is going to be alpha times L2 times the change in temperature. For the change in temperature, we know that it's 900 Kelvin minus 300 Kelvin, or it's going to be 600 Kelvin. For alpha, this is something that you'll have to look up. It's dependent on the material. For this example, we have acrylic, so alpha is going to be 75 times 10 to the negative 6, 1 over Kelvin. I should have clarified earlier, since L1 is the longer length, L1 is going to be the 60 centimeters, and L2 is the shorter length, so that'll be 40 centimeters. To be clear though, it doesn't really matter since we're just looking for the change in area. If you just rotated this 90 degrees, it wouldn't really change what the end result is. But now that that's been clarified, we have all of the values we need to solve for the change in L1 and the change in L2. So, thus, the change in L1 is going to be equal to alpha, which we know is 75 times 10 to the negative 6, 1 over Kelvin, times L1, which we know now for sure is 60 centimeters, times the change in temperature, which is 600 Kelvin. If we plug this into a calculator, the change in L1 is going to be equal to 2.7 centimeters, and then the change for L2 is going to be 75 times 10 to the negative 6, 1 over Kelvin, times 40 centimeters, times 600 Kelvin. Thus, the change in L2 is going to be equal to 1.8 centimeters. Thus, AF is going to be equal to L1, which is 60 centimeters, plus the change in L1, which is 2.7 centimeters, times 40 centimeters plus 1.8 centimeters. This means that our final area is going to be equal to 2,620.8 centimeters squared, our initial area is going to be equal to just 60 centimeters multiplied by 40 centimeters. So our initial area is going to be equal to 2,400 centimeters squared. If we want to find the change in area, which is what we were originally wanting to find how much the area of the acrylic panel will change, then our change in area is just going to be AF minus AI, or it's going to be equal to 2,620.8 centimeters squared minus 2,400 centimeters, or the change in area is going to be equal to 220.8 centimeters squared for our final answer. So, I hope this was helpful, and I will see you in the next one. Have a great day.